Hello class, and welcome to the world of related rates. So here will be an intro to the related rates, what we want you to do for this first section in first part of the next section on, 4.6, but we want to figure out what is a rate. A rate is how something changes over time. So what we'll take a look at here is, imagine we have a particle that's traveling along the red line. So I can show that on this red curvy thing, we have something traveling along there. This goes in both directions, but here I am just being a particle traveling along. My question for you is, as it travels along this curve, how is the distance from the origin changing? So we have something that's meandering along here, and you'll see as I start out going to the right here, it's getting further away from the origin. Now, as I turn back here, it's getting closer to the origin, and now as I go over here, it's getting further away. But if I look at this, I could figure out, well, how are my x's changing? Here my x values are increasing, and then it gets to here, now my x values are decreasing, and now my x values increase again. So as I move along here, the distances will be increasing and decreasing, but the x values will be increasing, decreasing, increasing, and the y values are negative, they seem to always be increasing. And so the trick would be to find some equation that does this, but in general, what we have here is three different rates. We have the rate of the x's changing, we have the rate of the y's changing, and we have the rate of the distance from the origin changing. Those are all three things. So what we need to do to mathematically look at this is simply, we want to take the derivative of each of those three variables, those three things that are changing, but we want to take it with respect to time. So we look, and in my original equation, none of these variables are t, are time. So I'm going to think of graphing them all separately with time on the x-axis. So we think of a new graph that has each of these. We're going to have three of the graphs. One of them is going to have the x value with respect to time. One of them is going to have the y value with respect to time. And the third one is going to have the distance from the origin with respect to time. And all three of those will have rates that will give us the distance that are happening. So up here we look at this and we say, all right, how do I do this? We just simply do implicit differentiation on each variable, but with respect to time. So this becomes 2d, and then we're taking the derivative of d as the variable with respect to time. That will equal 2x, but that was the derivative of x with respect to time, plus 2y, the derivative of y with respect to time. And what we now have is an equation that relates all three rates. So we know that you have to know the x, the y, and the d, and their rates to get the other ones. And usually what we'll do is we'll tell you some of this information, or we'll tell you how it's connected, and we'll make you solve for the one thing. So we'll give you information, for instance, of how d squared is x squared plus y squared. So you might be able to replace, or we might say, and we want to figure out what's happening when x is 2 and y is 3, And so we'd say, oh, x is 2, y is 3, I can figure out d, I'll know x, I'll know y. And then we'll tell you what one of the rates is, or two of the rates, and we'll have you figure out the third. So that's the type of problems we'll be solving, but first of all, we just need to do implicit differentiation on that. The next slide will give you a couple more examples on how to do this, how to relate rates of things that are changing. So here we have two formulas, both of them dealing with geometrical shapes. We said that the area of any circle is pi r squared. So how is the area related to the radius changing? And that answer is simply, well, okay, we can do this. It's the derivative of capital A with respect to time. What will that equal? It'll equal 2 times pi times r, but then I was taking the derivative of the radius with respect to time. So if somebody wants to know how is the radius changing, okay, when the area is changing at a certain rate, we can solve this for anything we want. We can solve this. Currently, it's giving us the prediction of how the area is changing with respect to time if I know the radius and how the radius is changing. We could also switch this and solve so we can get dr dt by itself, okay? And that would tell us how is the radius changing if I know how the area is changing and I know what the radius is. Now, as the radius changes, on a circle, we will get different, as the radius increases, you'll get different changes in the area. So this is telling us that dr dt, the rate that the radius is changing, will be the same as whatever dA dt is. And then I'm going to divide that, which is the same as multiplying by 1 over 2 pi r. Okay? All right. Okay, so that would have, again, that would be the rate that the radius is changing. If we know what the radius is, and we know how the area is changing, we can predict how the radius is changing. All right, and the last one over here would be simply, can I figure out how the rates are related for the volume? This would be the volume of any cone. It would be pi over 3 times r squared times h. So this would say that the volume, the dV dt, will be equal to, now this one's interesting because we have two variables over here. We have r and we have h. So we need to do a product rule, and let's think of the first thing in red there as being the first, and so we'll say this is the first, pi over 3r squared, times the derivative of the second. Well, the derivative of the second is just 1, but that was the derivative of h with respect to time. Now I do plus the second, which is h, and I multiply it by the derivative of the first, which is 2 pi over 3 r. But that was taking the derivative of r with respect to time. And so what we have is a related rate equation that says the volume of this cone, the rate that it's changing is equal to, and if we clean this up, we would say it's pi over 3 r squared, if I can write it, dH dt, that's messy handwriting, plus 2 pi h r over 3 dr dt. And so we've done our first step in making a related rate equation. So the homework should be just doing these steps and seeing how these things are related, and then next class we'll move into how to actually use this to solve and answer problems. Okay? Good luck on your homework. This completes what we need to do for virtual day this day, and I hope you all do well.